Hey guys, today we're going to be solving LeetCode question 1094, carpooling. This is a good medium level problem. The solution to this problem is based on heaps, specifically min heaps. Actually, there are other solutions to this problem, but the solution I'm going to present is based on min heaps. Okay. Um, I hope you've already read the question. I'm going to dive straight into the solution. What I like about this problem is that the way to arrive to the solution to this problem is very natural. It follows a very natural form of thinking. It is how you would think of trips in a real life scenario. If you were planning for trips, you would probably consider the trip that starts earlier than a trip that starts later. I know that's not a perfect analogy, but still, you would if the current month that you're living in is May, you would probably plan for a trip that begins in August before you start planning for a trip that begins in October or in December. So, following that analogy, not the perfect analogy, I accept, but what we receive as an input to this problem is an array of trips. Every trip is an array of integers by itself, where the first element is the number of passengers, the second is the start location. I don't know why they said location. I think that should be time, or maybe it's location. Anyway, that doesn't matter. And the third element is the end location. I might end up saying end times and start times, so don't get confused with that. Anyway, we'll receive an array of trips, and what I'm trying to say is we'll process them, we'll sort this array of trips by their start times, because we'll try to follow the natural way of thinking of trips. Uh, we would plan, or we would consider a trip that starts earlier than before a trip that starts later. Okay, so we'll sort the trips by their start times, and then we'll have a for loop that goes through the trips in this sorted array of trips, and then we'll evaluate the feasibility of every trip inside that for loop in every iteration. Cool. So you'll understand that evaluation part. That evaluation part is the crux of the solution. I'll get to that. Before that, I want to establish that we'll have two data structures. The first data structure will be the array of sorted trips, trips sorted by the start times. Okay, there will be an array that holds that information, the sorted array of trips, and they will be sorted by start time. The second is the min heap. Okay, the min heap will hold the context of the current situation in the car. Okay, it will hold information about all the trips that are currently being serviced by the car. Okay, that is what the min heap is for. And the trips in the min heap will be sorted by end time. Okay, now might not be, why are we sorting that by end time might not be obvious immediately, but I'll get to that. You will understand that. For now, just remember that the array will have an array of trips sorted by start time, and the min heap will have nodes or trips that have been sorted by end times. Okay, now let's go back to the for loop. So the inside the for loop, the let's say we are processing a trip. Okay, in this array of trips, let's call this trip current trip. Okay, we are processing a current trip. We are evaluating the feasibility. Evaluating the feasibility means we are trying to evaluate if the number of passengers of this current trip can be accommodated in the vehicle or the car. Okay, does the vehicle have enough capacity to accept, to hold the passengers that my current trip requires. Okay, that is the evaluation of feasibility. That is the evaluation of feasibility that I was talking about. Okay, so we'll have, the capacity in the car will keep on changing. Okay, so we'll hold that information in a variable called the current running capacity. Okay, so when we are processing any trip, the current trip, we will compare the number of passengers of this current trip against the current running capacity of the vehicle. Okay, the current vehicle running capacity of the vehicle will be the number of passengers that the car can hold at this point, at the point where I'm processing the current trip. Okay, the initial value of that running capacity will be the capacity parameter that is passed in to the function. Okay, that is the initial capacity that the car can hold. Now, how do I know what is the current running capacity? Okay, I don't know any information about the past, like of the things that have happened before this current trip. This is where the main heap comes in. Okay, basically what we'll try to get the current running capacity of the car, we will find all the trips that have ended before this current trip has started. Okay, I'll repeat that. I'll try to find all the trips that have ended before this current trip has started. Basically, I want to find all the trips whose end times are before the start time of this current trip. This is where the min heap comes in, because it already holds the trips that are currently being serviced by the car, and they're sorted by end times, meaning it will give me, whenever I um, remove an element from this min heap, it will give me, of all the trips that are currently being serviced by the car, it will give me the trip that will end first. Okay, and we'll keep on removing these trips from the heap until I have found all the trips that have ended before my current trip has started. The current trip that is being um, the evaluated for feasibility inside the for loop. Now, why am I trying to find all the trips that have finished before the start time? Because if they have finished before the start time, I can add the capacity that the passengers who were dropped off in those trips to the running capacity of the car. It has increased my capacity. It has increased the number of passengers that the car can accommodate, because those passengers have already been dropped off. Those trips have already been completed. So I have that so I have so basically we have to add that freed seats to the current running capacity, right? And now I can evaluate okay, this is the current situation of the car, and these are the number of passengers that my current trip needs. So I'll compare the running capacity and the number of passengers that my current trip needs. Now, if the current running capacity is greater than or equal to the number of passengers required that the current trip has, I can accommodate the passengers of this current trip, and the carpooling will continue. If at any point the running capacity is less than the number of passengers that the current trip needs, it means that the trip cannot be completed. And if even if one trip cannot be completed, it fails the entire solution. So we'll immediately return false for the entire problem at that point, because if it fails even for one trip, it fails the entire solution. Okay, and that's basically it. That's the entire concept of this problem, and I think this will become clearer to you when I start coding. I apologize for immediately talking about for loops and everything while explaining the solution, but I thought that was the best way to go about it. And so, if okay, I'll just give a quick walkthrough of what we are going to do. We are going to process the trips in order of starting times. Okay, the min heap will hold the context of the current situation in the car. It will hold all the trips that are currently being processed by the car. Okay, now I will, inside the for loop, not for loop. Now I will be considering trips by their start times. Okay, now I pick up a trip. I'll pick up the trip that is going to start earliest from my current time, and then I'll try to find all the trips that have ended before this current trip, and I will add the number of seats that have been freed by the ending of those trips to the current capacity of my car, and I'll compare that current running capacity, with the number of passengers that I need for my current trip. Okay, if the car can accommodate my passengers, I will continue with the carpooling. If it cannot, the carpooling schedule is infeasible and I end the solution. That is basically the entire concept of this problem. I'm going to proceed to the solution now. There is Swift does not have an inbuilt API for heaps, so I've already copy pasted this heap class from somewhere. It's actually a struct, but if you're not familiar with structs, just think of it as a class. And yeah, I think we are ready to start coding, so I'm going to dive straight into it. I'll be explaining all the steps. If you're not familiar with Swift, don't worry at all. I'll be explaining every step, and it's very readable, so you should be fine, even if you're not familiar with Swift. Cool. Let's dive straight into it. Cool. First things first, let's make sure we have at least one trip. Just putting it, a quick check there. Okay. Oh, sorry, there should be 0. We'll maintain a variable for the current running capacity. Okay. And we'll initialize this with the capacity, with the initial capacity of the car that has been passed into us. Okay, as an input. Now we'll sort the trips by their start times. Okay, this is the function to sort the trips, sort an array in Swift. Now this might look a little complicated what I'm going to type next, but please don't be bothered by that. I'll be explaining. So basically we are comparing start times. That's why we are comparing and then increasing order of start times. Okay, so basically the one this is the arrays are 0 indexed, so 1 here means the second element, which is the start location or the start time, and I'm sorting these strips in increasing order of start times. Okay, that's all that this is. Okay, let me call this the natural order of processing trips. Okay, as we discussed earlier. Now we will construct the min heap. The syntax for this is more convoluted, but again, don't be intimidated by it. I'm only constructing a min heap whose order criteria is by n times. Okay, n times, and this will hold the current trips being serviced by the vehicle. Okay, vehicle or car. Okay, so I'm constructing a heap. Cool. Passing it a closure. Okay, I'm just going to format this a bit. Okay, again a little complicated. Don't worry about it. Trips here are integer arrays. Trip to integer. This is a closure, okay, in Swift, but like not important to the solution, so that's fine. Just thought it's best to mention it. Okay, and the min heap holds trips sorted by n times. So trip 1, 2, 2 means the third element, which is the n time, sorting by n times. So trip 2, 2. Cool, that's done. Now moving on to the for loop that I was talking about. Actually, I should call this the natural order of processing trips. Okay, and I'll just call this sorting trips by start times. Yeah, this comment applies more to the for loop is what I feel. Current trip and sorted trips. Okay, we'll consider the trip that is going to start earliest from my current frame of time. Okay, so we'll first update the current running capacity of our car by adding the seats freed by the trips that have ended before the start time of my current trip. That sounded complicated even as I was saying it, but I'm going to basically find all the trips that have ended before the start time of this current trip and add that to the running capacity of my car. That is the first thing that I'm going to do in this for loop. So let's do that. Let's the start current the start time of my current trip. Okay, I'm going to introduce long variable names and just extra variables where I'm going to introduce variables where I don't need them just for the sake of explanation, just so you understand it better. Okay, just wanted to put in that disclaimer. So current trip 1 will give me the start time of the current trip. So while main heap is not empty, okay, meaning there are still trips that are being serviced by the car, this condition will definitely be true, like the main heap will be empty the first time. Okay, this condition will be false actually the first time that we enter this for loop, because there will be no trips that have started yet, right? So just a small point I wanted to make there. So I'm trying to find all the trips that have finished before this current trip. Okay, before this current trip has started. So that means current trip start current trip is equal to min heap dot peak. So peak will give me the top element, okay, of the heap, the trip that has ended earliest of the trips ending early. Okay, dot peak force unwrapping this. That's a Swift directive. If you're not familiar with it, don't worry about it. Don't worry about it. It's not important to the solution. Okay. The start of the current trip is greater than or equal to is fine, the end time of the top of the min heap. Okay. 2 is the end time or end location. So the finished trip. So basically, if a trip has already ended, we'll also remove it from the main heap, because that means it no longer represents the current situation of the car. It has already ended. So we're going to remove it from the main heap. Okay. So let's remove that. Force unwrapping, ignore if not familiar with Swift. We'll update the current running capacity of the car, because those seats have been freed by this trip that has finished. So add the number of passengers that this finished trip took, okay, and has freed now. And we'll keep doing this. We'll keep trying to find trips that have ended before this start time, before this new current trip has started. So we'll keep going through the heap until we can keep finding more of such trips. Okay, now our current running capacity would have been completely updated by the end of this while loop. Okay, current completely updated at this point. I'm going slow, but I just want to make sure the concept gets across. Okay, so basically I'm going to compare the current running capacity with the number of passengers that my current trip has. Okay, if the current running capacity is greater than the number of passengers that my current trip has, it means the car can accommodate the number of passengers required. Okay, so that basically means we'll have to update the main heap, because we have to update the context of the tasks being serviced by the car. Okay, we have to add the current task to the current sorry I have to add the current trip to the trips being currently serviced by the car. Okay, so for that I'll insert the current trip in the min heap, updating the context of the car, adding the current trip to the car. And if I've added the passengers of the current trip to the car, I've also reduced the running capacity of the car, so I have to update that as well. Current running capacity, and I'll subtract the number of passengers of the current trip. Cool. And if the current running capacity is less than the number of passengers that my current trip requires, it means that my car has run out of seats for the current trip. And if that happens for any trip, that means it has failed for the entire solution. My carpooling schedule is not feasible, and I'm going to return false immediately. I don't need to evaluate any of the trips that come later, because even if one trip fails, it means that the entire schedule is infeasible. And if we make it out of this for loop, it means that all trips were feasible, all trips could be completed successfully, and that's why the entire carpooling schedule was feasible. And that means I just have to return 2. And that's it. That brings us to the end of this solution. There's nothing more to add to this solution. Cool. Let's run the code and see if it works fine. Okay, what's the error? Oh, I'm sorry. I need to make this a var, because I'm a variable, because I'm changing the main heap. Okay, Swift error. Let's not concentrate on that. Okay, that worked fine. Let's submit it. Cool, that worked fine. I hope I did a good job in explaining the solution. Well, happy lead coding. Have a good December. Bye.